So the Intel's new Cascade Lake-X platform is finally here. To be perfectly honest with you, when I first heard about this whole launch, I wasn't that much interested in it, because to my eye it didn't really look that like anything spectacular. It's still a 14 nanometer CPU launch, so it just kind of seemed like that Intel tries to fight AMD, because AMD has been putting a lot of pressure on Intel's CPUs recently with their Ryzen and Threadripper CPUs, and makes the corresponding Intel alternatives look kind of bad due to very high price tags. So to my eye, when I first saw about this whole CPU launch, it only looked like that they will be releasing the same stuff again with significantly lower price tags. So today we will be testing out one Cascade Lake-X CPU, which I managed to get my hands on. So this is the 18-core 10980XC, which is the highest end option for the whole Cascade Lake-X CPU lineup. So this is, as you would guess, an engineering sample, so this is not a retail CPU, as I'm filming this whole video a bit ahead of time of the original launch, so there aren't retail CPUs out there available yet at the time of making this video, but it is the same thing anyways after all. So the overall like gains or improvements of this whole launch are kind of minimal. So the stated improvements on paper are mainly in the like connectivity options. The maximum memory capacity has been increased from 128 gigabytes up to 256. The like the maximum fully rated speed of DDR4 memory has been increased from, I think, 2666 up to 2933, but in the end that doesn't really matter anything, because we still have to see how the memory controller can handle the quad channel memories at different memory frequencies, because the variation in terms of memory controller quality has been quite high with all the Skylake-X CPUs that I've tested so far, where with the 12-core 7920X still being the best, as that CPU could do almost 4133 MHz with 12-11-11 timings. So and that was on water, and all the other CPUs, or pretty much most of the other CPUs that I had, could not do even 4 GHz fully stable with that timing configuration, even not on air or water, or even on sub-zero cooling. So the variation of memory controller quality is quite high. So we can see that does the the increased supported level matter anything in the end when we talk about like overclocking, because after all, like XMP kits or XMP profiles are literally just overclocking profiles made for memory kits. So it doesn't really matter what the maximum stated is, because the available kits that you can buy are significantly higher than that 2933 or 2666. Then of course they state that they have increased the PCI Express lanes from 44 to 48. Again, not a big thing, as the maximum graphics card or multi-graphics card configuration has been decreased from 3 or 4-way SLI down to 2-way SLI now. So the mega multi-GPU configurations have kind of disappeared from the high-end market. So nowadays it's more about just 1 or 2 very high graphics cards, and then lots of like PCI Express related storage devices like M.2 drives and so on. So I think the benefit is pretty much there. Then just some improved Wi-Fi and some improvement in the turbo boost technology, so we can I don't know, maybe I don't know how the improved turbo boost works, but to my eye this whole launch seems to be like exactly the same launch as the original Skylake-X 7900 series. So they just have given a bit of like clock speed bumps on each of the core counts that they are releasing now. Of course they already increased those values with the Skylake-X refresh CPUs. But now, so they are just bringing the core counts ranging from 10 core all the way to 18 core, except the 16 core part. So there's no 16 core CPU coming out. So just 4 CPU models, 10, 12, 14 and 18 core. And the one that is here is the 10980XE, so the 18 core flagship model. The biggest thing about this launch, as I stated in the beginning, is just the reduced price tag. So now the price of the 18 core CPU has come down from the stated $2,000 recommended retail price down to a bit under 1,000. So the overall price reductions on each of the core counts has been around 40 to 50%. So that is a significant drop, like a huge drop. Maybe one of the biggest drops ever in the history of computers in this, like in many years. So that's the thing that AMD has done to the high-end consumer. So you can all thank AMD for putting pressure on Intel that makes the prices or the price tags of different CPUs that they have released to come down. So now more people can afford these X299 and LGA 2066 CPUs and so on for workstations, high-end gaming computers, you name it. So on this video we will just take a look at the CPU, how it performs with the X299 Dark. Can it run well on the X299 Dark? So is there any point on upgrading a motherboard if you happen to get one of these Cascade Lake-X CPUs? There will be some refresh models coming out from many vendors, but I'm still sticking to the X299 Dark, so we will be testing the CPU on that. Now you do need a BIOS update to run these CPUs, so you cannot run the new CPUs with an old BIOS like you could do with the Skylake X refresh CPUs like 9980XE. I could use an original 7980XE BIOS. You get the idea anyways. But yeah, so there will be BIOS updates for the motherboards as well as for the Dark. So if you happen to buy one of these CPUs, you just have to update the BIOS before you place the CPU into the socket. So I think we can just get the system ready and we can take a look how the BIOS looks like now with the Cascade Lake-X CPU in. And that is how the overall setup looks like. So X299 Dark, the 10980XE is underneath this AlphaCool CPU water block over here. Then we have in total 4 sticks of Samsung BDI A1 PCB, so 2 sticks of Trident Z 3600 Cas16 and 2 sticks of Trident Z 4133 Cas19 sticks. So these are good for well over 4000 in quad channel 121111, and both kits can do even 4200 plus 121111 on a mainstream platform with a very good IMC. So the configuration is pretty good. Of course, the older PCB design cannot do as great like daily configurations as A2 PCB design, although at least for me when I have been testing, I have always had it so that with the newer PCB kits I'm almost all the time limited to Command Ray 2 only, so I cannot run Command Ray 1 well with the newer A2 PCB design. But anyways, so the power supply is the Superflower 2000 watt 8-pack Platinum, so that's very large overkill for this current configuration, but it doesn't really matter. I need the high capacity for like extreme overclocking when I have both CPU and graphics card on LN2. The graphics card is just Galaxy 710 GT for displaying the video on the monitor. Then Apacer SSD for the actual operating system. So we don't really need anything else. So as I said, you need to update the BIOS before you can boot this Cascade Lake-X CPU on the X299 Dark, as the CPUs are not supported out of the box. I'm not sure that will EVGA supply the new BIOS straight out of the box with the new boards from the retail stores once the Cascade Lake-X has arrived in retail stores, but we will see about that. But I have flashed the Cascade Lake-X BIOS to the middle position on the BIOS switch, as this board has 3 BIOS chips for very trouble-free use. So now we can just clear the CMOS and boot the rig. And that is how it looks like when you arrive in the BIOS, so it doesn't really differ that much at all from the previous CPUs like 7980XE or 9980XE. So currently I'm using just a beta BIOS, as at the time of making this video there's still no retail BIOS available yet, but it doesn't really matter. The end result will be the same anyways. So what you can do is you can use the well, if you want to overclock on the X299 Dark, you could just use the OC robot if you are, let's say, a beginner to test, but I haven't still tried that. I think I will make a separate video about that that utility, so I will just do the whole process manually as before. So I will just load my profile and I will go through it with you. So it's quite obvious or expectable that these CPUs overclock a little bit better on air or water cooling than the previous ones. So I will just start at around like 4.5 or 4.6. So and 33 on the mesh. So these values generally worked well. So every X299 CPU that I tested did 3.3 mesh or above on water cooling, so that should be fine. CPU input I will run at 1.95. I will enable the extreme voltage mode for this scenario because I will be running the very high memory profile. So you just have to, if you want to do like really high testing on memory, even on air or water cooling, you have to enable the extreme voltage mode on the X299 Dark to be able to put more than 1.6 on the memories. I mean 1.6 DRAM voltage. So that's only for that purpose. So don't be afraid about this setting. Input, you should try value ranging from, let's say, 1.85 to 2.1. This does affect the temperatures, but actually in my testing it doesn't really do that much of a difference on air or water cooling. So usually a value of 1.9 or 1.95 is just fine to reach the best possible clock speeds on air or water cooling. Then vCore, be very careful with these CPUs, as we have seen this numerous times already. So if you are unsure about your cooling solution, you could even start as low as 1.1 volts or even below that. Of course you have to set the core frequency accordingly if you only use that low voltage, but these CPUs really get warm very fast. And again, I'm using a very strong custom water cooling in my testing sample over here. vMesh, or the mesh voltage, you can run this quite a bit higher than the actual vCore. This does not affect temperatures that much, so this is only for making the actual mesh clock stable. So I will just put 1.3 volts over here. It's totally fine. The vDroop means load line calibration on the input voltage. So if you want to enable load line calibration on the input voltage on X299 Dark, you have to set this disabled. So disabled means that it disables the whole vDroop functionality. So it means that the whole voltage drop is compensated when it's set at disabled. There is no load line calibration for the actual vCore, as that is set inside the CPU. So that is not controlled by the actual motherboard. vCCSA and vCCIO. vCCSA is not used on Skylake-X, as the voltage controller is inside the CPU, so the voltage does not come from the motherboard. So you could just leave this at auto. I'm just setting it identically as the vCCIO. vCCIO does affect base clock and even the mesh overclockability a little bit, at least on LN2. So I would just set these at, let's say, like 1.25 if you are running really high memories like I'm here. But if you are just doing like very quite simple daily memories, you could just set 1.15, 1.1. PCH, not needed to set it, but I always set it manually as, well, I don't think I have to explain that, but you can just leave it at auto. Then Anchor voltage offset. So this is the internal system agent voltage. So this is the actual memory controller voltage of the CPU. So it's controlled as in offsets, not by actual like fixed value. So the range on the right in the description part is quite good. So usually I use, well, if I test memories like this, so 3800 plus with tight memories, I run 400 to 450, both on air or water and even on LN2. If you are just doing like normal memory, I mean like XMP stuff, you could just put maybe like 200 here or 300. So if you use 200, it should give maybe like 1.15 roughly. So you could start at around that. Then for memory, if you want to copy my profile, you can do that now. I will show all the settings. So 3800 megahertz memory frequency multiplier, 1.86 volts on both sides, 12, 11, 11. So these are not linked on Cascade Lake-X, so I could run one value lower on the actual TRP compared to TRCD. So 12, 11, 11, 28, 4, 6, 6, 14 and cache write latency of 9. In Buildsoy's videos he uses way too loose values on the cache write latency and other things, so that's not very well performing. So that's why his scores aren't often that good. So he definitely has to upgrade his memory kit. TRC, I leave this at auto. Common Ray 1, as I said. Write recovery time of 10. TRFC is at 240. The lower the better on this one. Then the refresh interval, the higher the better. So I just set it at max value. So 32,767 is the highest I can run. Then this setting is quite complicated. So this is the T, V, TR, S and L. So the tightest values I can run here is 3 and 8. Optimal would be like 1 and 6 as on mainstream platform. I just cannot get them stable for some reason. TCKE is at 4, which is the lowest reasonable value most of the time. Then the third timings is 1, 1, 2, 2, 5, 5, 4, 2, 6, 4, 6, 4, 6. So this is quite good. I have tested these many times over and over again. So if you want to try these settings, you can just copy these and try yourself. Then in the advanced part, there aren't that many things that you should be looking at, so I haven't disabled anything. Disabling speed step or the seed states doesn't make your CPU any more stable than before, so it's not really needed. So I just keep all these settings enabled. CPU storage, nothing. PCI-E you could set at different PC Express generations, but that is not really necessary. If you are just, let's say you are running some old graphics card like 7970 on LN2 on this platform, you have to set it at Gen 2 instead of Gen 3 to get rid of most of the code bug and code boot bug issues. So that's the only case really when you might have to set a lower generation on a graphics card if you are just testing old stuff like that. But auto is the best value 99% of all times. Nothing in PCH, SATA, nothing. So we have AHCI instead of RAID. USB, nothing really. Nothing in power. Onboard, you could disable the onboard LAN, creative audio, as media SATA controller and USB 3.1. But of course for daily use I will keep them all enabled. Then the important thing is the hardware monitor configuration. So you can use this for many things. So if you have the whole board set up in a case like how you would have it normally, you can use the onboard debug LEDs as some kind of monitoring thing. So you could use it as like really accurate like multimeter type thing. So you could monitor, let's say, the actual V-core. You can monitor the actual CPU die temperature, the PWM temperature, so you can do it for many things. And you can also vary between two values, so you can just lock it at sensor 1 or sensor 2 or sensor 1 and 2, so it will change constantly between the two, or it can cycle through all the voltages, cycle through all the temperatures, just select CPU die temperature. So it really depends on what you want to monitor. So if I, let's say, set sensor 1 and 2, on sensor 1 I could set CPU die temperature, so that's the thing you want for LM2 to follow that and know if you have possibly cracked your thermal paste. And in sensor 2 we can, well, there are many things, so you could set it at the actual 6-pin power connector, VCCIO VRM temperature, is this PC Express slot, memory VRM temperatures, CPU VRM would be the one you should choose, PCH, no, it doesn't really matter. Different cores, so CPU, the first core and the last core, and then all the different voltages, so mesh voltage, CPU PLL. CPU PLL actually is for Cascade Lake-X. But yeah, so I would just set sensor 1 to CPU die and sensor 2 to CPU VRM. So it will cycle between these two, because these are the important ones you generally want to follow, as even with the Cascade Lake-X, the VRM definitely gets hot over time if you stress the CPU when it's overclocked for long periods of time. So it's not really different by any means in terms of that. And nothing really on these last two options. Boot. So if you want to install Windows 7, you have to enable the Windows 7 installation to enable the PS2 emulation on your USB ports to have them functioning. If you want to install, let's say, Windows 7 or similar old operating system, you should set this at legacy. And if you want faster boot, you want to install Windows 10 or similar, just keep this at UEFI. But as I'm using Windows 7 now, in this case, I will keep this at legacy. And then we can just go to the last page and save profile. So I will put it at daily, or not daily, 10980xe test. Then I just double check that nothing really on. I generally double check the voltages, so there's not like any stupid mistyping. So yeah, now we can just press F10 on our keyboard and save and exit and see how it looks like in the actual OS. And now that we are in the OS, we can just open CPU-Z to check all the info. So here we can see that the CPU is reading, the CPU-Z is reading the CPU incorrectly. So in the top line we have Intel Core i9 9980XE, but Cascade Lake-X, and in the specification line we have Intel Core i9 10980XE at 3 GHz. So it's just reading it incorrectly, but it doesn't matter, as this is still the oldest or the newest version at the time of making this video, but it doesn't read the Cascade Lake-X CPUs correctly. So the CPU is currently at 4.6 GHz and it's reading the V-core correctly. So we set at 1.2 volts, but of course it states here that it's VID, but it doesn't matter. In memory tab we can read the mesh is at 3.3 and memory is at 3800 MHz, 12, 11, 11, 28, 240, common rate 1. So for simple testing, of course, this isn't the most efficient way to overclock these huge core counts, because now we are just running like fixed overclock across all of the cores. The silicon lottery, as meaning it's not just about the quality difference between actual CPUs. There's a lot of quality difference between the actual cores. So if you really want to max out your like daily overclock for different situations, you should use the per core function, because the quality of the actual cores really matter a lot. And now with the latest BIOS, I mean, and even on this board, you can overclock each of the CPUs independently and see and set independent voltage for on each of the cores. So that's one thing thanks to the FIVR. So you can set, so you have per core voltage and per core clock, but it's just much easier to test the CPU at a fixed clock speed across all of the cores. So we will just use Cinebench R15 for quick testing now, but for like daily stability I would use at least some kind of Prime95, so even the non-AVX one, and you should just utilize the AVX negative offsets to compensate the higher load of different AVX offsets, because the new CPUs or the new CPUs like the Cascade Lake-X, they have many AVX instruction sets that it supports. So there's AVX1, AVX2, AVX512, and the 512 is a really tough one. So you can never run AVX512 or any AVX load stable at the same speed and voltage that you can pass Cinebench at. So you just have to remember that. And but for now we will just use Cinebench for quick testing, so that we can easily compare that what I got with the 9980X CPUs and see if this is any better. For temperature monitoring I'm using Core Temp because it's just very light program and it's very easy to use. So now we can just test it at 4.6, and the cores are immediately ramping to like higher 60s and like mid 70s, but it passed without any issues, and the score is 4670. So it's pretty much on par with so far with the 7980X and 9980X, so there's not like seeable or visible gain from the CPU, so there doesn't seem to be that kind of like, let's say, IPC improvement. So it's just pretty much the same CPU with just new model name on it. So 4.6 went really well. So yeah, I had some weird issues with the Elite software, as this is a recycled OS, but yeah. So there is a new and updated version of Elite for the Cascade Lake-X CPUs. So you can again monitor all of the main voltages and temperatures with this. So you can see that there's some overshoot on the actual input voltage, as it was set at 1.95. It's reading at 1.987. Memory I increased a little bit to 1.89. So there's like 20 millivolts almost of overshoot on that. Then temperature of each of the physical cores. You can use this for setting some of the voltages, but I generally don't do that in the OS because there's some bug often with the Elite that it hangs the whole system if I set anything in the OS with this. So I generally just use this for monitoring and overclocking the CPU. So now that 4.6 was stable, we can put 4.7 on the bottom core to set it at all cores and apply. Then if we open CPU Z again, yeah, there's the power setting thing. I will set it at high performance. Yeah, so 4.7, so it worked. And now we can quickly see if it's still stable. So 4.7 on the core, same voltages, same mesh, and run. It's running. It does show in higher temperatures because the core frequency really affects the temperatures, as it increases the amount of current that the CPU is pulling from the motherboard. So 4748 at 4.7, so it's very good. And since that 4.7 passed well, still at 1.2 volts and 1.95 input, I now increase the clock speed to 4.8, so we can test if it's still stable. Seems to run. Temperatures are now ranging from hottest is at 78, lowest was 66, so the variation is very high, like 10 degrees. Score is 4829, so it's very good as it's all still stable at 4.8. Now we can open ELED again, set 49, and it should update on the CPU-Z. It's sometimes a bit slow. Well, as it's still quite new, so the ELED isn't still working like 100%, but it will be fine with the retail version. So now it's at 4.9, and let's see if it's still stable at 1.2 volts. Seems to run, and temperatures are now the hottest core was 80 degrees. At least two cores were at 80, 3 cores actually, and coolest core was 68, so it's definitely going up with the actual core speed. So the score was 4931, so this is very good. So this is definitely the best 18 core CPU that I've had. So this is the 4th 18 core that I have my hands on. So I had one 7980XC and two 9980XC CPUs, and none could do 5 GHz for Cinebench on watercooling. Exactly the same cooling, same board, same memories. The best were the 9980XC, and they were doing like 4.95, 4.9 something, and the 7980XC was around 4.9 as well. So now we can try 5 GHz, but this will definitely crash, I'm pretty sure. So now it's reading at 5 GHz. 5 GHz on all 18 of the cores, as we can see over here. But this will surely crash, I'm absolutely sure now. Yeah, so it's getting unstable. We could try, let's say like 3D Mark 11 physics or something, as this is quite nice. It tests the CPU and memory quite well. Memory really affects the score of the 3D Mark 11 physics. It's easier to pass than Cinebench, so let's see if we can get any like reference score. So so yeah, it doesn't seem very stable, but it's a bit about luck as well. So yeah, so we can so we can pretty much state that it's not stable. So now we pretty much just have to increase the voltage. I really want to do that in the BIOS, just because I'd like as the software might bug and it will not save the voltage. So if I reboot in between, it will not save it for the next boot. So it's better to do that in the BIOS. And as we already know that what we were doing, we can increase this to, let's say, well, let's put it at 5 GHz straight. And let's put 1.24 on the V core. Same mesh voltage, 1.95 input. See if we can boot 5 GHz happily. So it booted 5 GHz happily at 1.24 volts. So, well, let's try the 3D Mark 11 again, just out of interest, as we have very good memories over here. So 5 GHz, and we have all the core temperatures measured. .79 FPS or so it did pass now, and we have a score of 28,000, so 88.90 FPS. So it's funny, so it's worse than what I got at 6 GHz on 9900K. So it doesn't really scale that much from the actual from the extra cores after some point. So as that passed happily, now we can try. So now I'm trying 5 GHz again with 1.25 on the voltage. Damn, it's very on the edge. yeah, now it passed, but quite barely. So 5028 score. So that is pretty much the same, or it's pretty much on par with 7980XC and 9980XC. So yeah, there doesn't really seem to be any IPC improvement. So now we can just see that the temperature was ranging from 72 degrees on the lowest core and up to 88 degrees, and somewhere there were many cores at 87. So this is pretty much the limit in terms of temperatures. So this is what I meant about the starting at low vCore value, because they really get hot very fast, even if you have a very strong custom water cooling. So 5 GHz pretty much the limit what I can do for Cinebench. 5.1 would need like very cool ambient room temperature and maybe 1.3 volts, so that is a bit risky. So that's why I don't want to push so high that fast, as it will go nearly 100 degrees, or it will go near 100 degrees very fast. So now what we could do is we could test the highest possible cache or the mesh, and we could actually use 3D Mark 11 for that, because it seems to stress the mesh more than the Cinebench, for example. So now we had 33 running, so we could just increase to 34. The mesh is much more important on X299 compared to the, let's say, the standard cache on the mainstream platform. The cache doesn't really seem to affect performance that much on most of the mainstream CPUs, but on X299 it really affects performance by quite a bit. So now we have it set at 3.4 GHz. So let's see if I can pass. So the best I had was 3.5 on the better 9980XC, I think. That was with voltage from 1.3 to 1.35. So let's see if 3.4 is stable. So it's like 1 FPS more maybe. So it did pass at 28,000. So 28,749 score. So it's very good. And now we can try even higher. So we can increase the mesh to 3.5. Check that on, or double check that on CPU Z. So 3.5 on the mesh. And just try it again. 3.5 at 1.3 volts is already very good, if it's stable, of course. So yeah, it's definitely scaling. So over one more FPS again, and the score is 29,092. So that is definitely great. So now we can just push it a bit more. So this is already the best cache or the best mesh I've had this far. So let's set 3.6 and try to run it again. So yeah, so that is the limit at 1.3 volts. So what I can just do now is that I can try to set the mesh voltage to, let's say, 1.35 and see if it's stable at that. So yeah, that is definitely the max in terms of mesh. So 3.6 doesn't even boot into Windows when I have set the mesh voltage to 1.35. So it passes even Cinebench very happily at 3.5. So in that regard, it is probably the best. It's probably the best mesh that I've had on air or water cooling, or on par with the 7900X and the better 9980XC. So 3.5 and 5G. So quite nice score. So now we can quickly. So yeah, and now actually one of the cores went to 90 degrees. So I'm afraid to push this higher in my current ambient room temperature. So I will not be trying 5.1 at 1.3 volts, so because that will go to 100 degrees instantly. So if we want to try for 4 GHz, same timing profile. We have to just set the frequency multiplier to 4000. We will need a bit more voltage for this, so I will just set it to 2.02 straight. We don't have to touch the timing table. It should do this exactly the same profile as it was the same with the 7920X, but we probably have to manipulate the voltage over here to have any chance on posting this successfully. So I might try still at 400 because it's already at 1.375 with 400 offset, 1.25 VCCIO and so on. But I don't think this will pass. So if this does not pass, it means that the like bumped like default supported memory frequency, it doesn't really mean anything. So it's just a paper value, so you still have to test yourself what your particular CPU can do. At least none of the sticks turned red, so it's very nice that the Dark has the LED light for each of the memory channels, so you can easily determine if some of the sticks failed to post. So it did post, but it doesn't mean that it will be stable in OS. So well, since I'm testing a memory configuration like this, the best thing to test it is to run Geekbench3 or 4. But if you are just testing for a maximum daily configuration, you should run something like HyperPi. Oh, well, yeah, it's definitely not stable, but you should run something like HyperPi 32M on all of the CPU cores or threads. So we can go down in the OC tab and set this to, let's put it at 500, as I'm curious. 1.3 on VCCIO. So yeah, so it's not booting. So we can easily confirm that this CPU cannot do 4000 MEMS because it's already I already validated it myself. So I used exactly the same memory sticks with the 7920X, and that did 4100 plus very easily. So so yeah, there's no gain on the IMC. And now I have been running Prime95 26.6 for quite a while now. So and some of you guys always moan that I'm only running that very tight like memory configuration at very high frequency and with 12-11-11 timing. So now I just put the memories down to like XMP level. So now it's at 4000, 17, 18, 18, 28, 360 command ray 1. So this is with 1.45 volts. So the Dark can definitely do like very nice daily configuration in quad channel. So if you have really nice like A2 PCP Samsung Beta, you can surely do 4200 daily with good IMC. So now I've been running the Prime95 26.6 as this is the non-AVX one, and even that is putting a lot of pressure on the CPU and on the VRM. So I'm running it at 4.8 GHz across all of the 18 cores at 1.2 volts. I lowered the input voltage to 1.85 to preserve some heat, or I mean not to make it so hot. The cores are ranging from like 72 all the way up to 89, so the variation is very high. So it's already peaking close to 90 degrees on the hottest cores, so that is really a lot. And now if we look at the onboard debug LED, so the 52.2, that is the CPU die temperature. So in that regard, the CPU die isn't that good for like daily purpose if you want to monitor the VRM, I mean the CPU temperature, because that is way off from the actual cores. So that is, I'm not fully sure where the CPU die temperature is being measured, but it could be like from a bit further away from the actual cores, and that's why it's not so accurate. To, if you want to know the actual core temperatures, that is only really good for like on LN2 when you want to determine that is your paste quality still good. For that is absolutely amazing. It's one of the best things I've ever had for LM2 overclocking purposes, and that 94 degrees is pretty much the VRM temperature, but this has been running for quite a while. So even with that, so it's definitely getting hot. But of course this is a very extreme test, as the amount of watts that is going through is definitely a lot. You don't really run something like this at 4.8, 1.2 volts. So 4.8 doesn't sound that high compared to what we have on a mainstream platform, but on a CPU like this, that is absolutely huge. So if we look at with infrared thermometer, it was 72 somewhere. So this is like the caps, 72, 73. So I'm not fully sure that is the contact on the heatsink the best. But yeah, so the hotter one is the actual VRM temperature. So it's at 98 right now. So based on this, I really recommend that you don't try something like this as the first thing you do on a platform like this. So you can easily see that it's very hard, even for a high-end motherboard like this. But anyways, the X299 Dark can definitely handle the high load of the Cascade Lake-X. So it's not different at all from the original 7980XE or 9980XE. So in that regard, the Dark is definitely up there and ready for the ready for the new Cascade Lake-X CPUs. But even when it was still it was still below 100 degrees on the VRM highest, but very close to 100 degrees. That already shows that how important airflow is on the VRM heatsink. So of course you need to have a strong heatsink solution on your motherboard's VRM, but the airflow is really a key. So the two small fans really are really good on the VRM heatsink, but even that doesn't seem to be enough to keep the VRMs really cool. So it would be very advisable to run some dedicated airflow from your like case fan or from a separate fan like this across the whole VRM heatsink area. Luckily, Dark also has the quite large backplate, like heatsink backplate on the backside of the board, directly behind the MOSFETs on the motherboard. So if you can aim some direct airflow around the socket area and the VRM heatsink, that is definitely great. So do that. So I think I can pretty much say that this is stable now based on how well it runs at 4.8 at non-AVX load. Of course this is non-AVX, so if I was running some of the AVX instruction sets like the AVX 512, it would be absolutely intense. So if you are going to test on the newest Prime95s, please start at a very low V-core value like 1.1 or even under. If you are just running a simple air cooler, please, because these temperatures are absolutely insane. So I think we can stop this now. So that's pretty much it for testing the daily memory stability. Well, Geekbench does tell a bit, but it doesn't really stress the entire capacity. So you could run into some issues if you do like rendering when a lot of the memory capacity is being used. So the best thing would be to run. Well, first of all, you can run Hyper-Pi 32M on each of the cores and threads, as I already demoed in some of my other videos. And then you should run something like the HEI mem test in operating system and open as many windows needed to test the entire capacity of your memory. And if you get it run on all of the executions up to 100% without any errors, that will be definitely stable. But you can, well, the issue with the Hyper-Pi 32M is that you cannot run more than 16 cores or threads, so that's a little bit problematic. But even that is quite tough. So now that there is the past Hyper-Pi 32M benchmark run across the maximum amount of cores or threads. So it passed very easily at the 4017-1880 mark. I tried 4200 with my sticks, but as these are A1 PCB, it's not really stable, at least with Command Ray 1. So, and it also requires very nice IMC. So the 7920X can definitely do that, but not this one. So well, this already shows that it's very, very stable. But as I said, if you really want to be absolutely certain that your memory overclock is stable, you should be running many executions of the HCI mem test. So well, I'm not using the paid version, so I cannot run too much capacity per execution, so I can only run up to 3.5. So if you want to really test the entire capacity, you have to open many executions of the HCI test with 3.5 each. If you don't have the paid version, and I'm expecting that you will not be buying for very small use like this, so just open many executions, it will be definitely alright. And if we just look at Task Manager, it's going up. So now it's using 12.4. If we put 3.5 again, it's going up to 15.8. So that's just the way it will do. So you get the idea anyway. So what you want to do, just open as many so it's close to the maximum, as close to maximum capacity as possible, and then if they all pass up to 100% without any errors on any of the executions, then you can be pretty sure or pretty certain that the whole memory configuration is fully stable. And this is much easier to use than the old DOS version of memtest. Alright, so on to the conclusion. So sadly the video ended up being way too long again, but I really wanted to go through all the aspects of this new CPU from Intel, how it runs on the EVGA X299 Dark, how do you overclock it, and then how it compares against the previous CPUs in the same core category. So when looking at the graphs, so in this graph I compared the Cascade Lake-X 10980XE against the previous 18 core from Intel, the Skylake-X Refresh 9980XE. And I also separate the thousands of the Cinebench and the Geekbench scores so that they all fit better in the same graph with the X265 4K results. Because if I didn't separate the thousands, the graph would look kind of weird and you couldn't really easily like see the different results and like make a conclusion that which one is doing better. So this should help at least a little bit. So when looking at the first result, so Cinebench R15 at 4.8 GHz, we can actually see that the 9980XE scored 18 points higher, so 4,847, whereas the 10980XE scored 4,829 points. Keep in mind that there's always some variation between the actual runs, so you could run exactly the same test 1,000 times, and after each of the runs you could get a different score. So if there was like real IPC improvement, it would show up immediately on these tests. So you don't have to run like dozens of different gaming tests to determine the performance of a CPU. You can just run the most known CPU benchmarks to see the actual performance of a CPU quite quickly. So and also both CPUs were run on exactly the same motherboard and same sticks of memory. So 3000 MHz with 12, 11, 11 timings, and all of the sub timings were identical for both the CPUs. So you cannot get any closer than this pretty much. So we can already see that both CPUs are pretty much identical based on these results. So at 4.9 GHz, the 10980XE scored 10 points higher this time, and it's very close call on the Geekbench3 as well at 4.8, so 80,237 points for the Cascade Lake-X and 80,000 points, 126 for the Skylake-X Refresh. The X265 4K is no different, so 10980XE scored 34.752 FPS and 9980XE scored 34.706 FPS. And keep in mind that X265 4K can utilize the AVX instruction sets, whereas the Cinebench R15 and most of the stuff in Geekbench3 cannot. So yeah, So what kind of conclusions should I make of the 10980XE and the Cascade Lake-X launch overall? So it is pretty much the same thing. So the same thing as the original Skylake-X 7980XE and the 9980XE Skylake-X refresh. So the 10980XE is soldered just like the 9980XE, but it still runs very hot. So it runs hotter than a deleted 7980XE because 7980XE was with conventional thermal paste, and if you ran liquid metal between the die and the edges or just direct die altogether, you could get a little bit better temperatures because liquid metal just has a little bit like thinner layer than what indium solder has, and therefore you can get a little bit better temperatures that way. So temperatures are pretty much the limiting thing with this CPU when testing it. So there's no way to go any higher with just ambient based cooling, what I already got. So the EVGA X299 Dark can definitely handle this new CPU from Intel. So I actually managed to pass Geekbench3 at 5.1 GHz with 3.5 mesh and everything, with 1.285 set on the vCore and 1.9 on the input, and that scored quite nicely, so well over 90,000 after I realized that the newest versions of Windows 10 actually score better in Geekbench3 than the previous operating systems. And when I had quite cool ambient room temperature, I also managed to pass Cinebench R15 at 5.1 GHz. That is absolutely amazing. I used vCore 1.315 for this scenario, but you can already see that the temperatures, the hottest cores are well over 90 degrees already. So the temperature is pretty much the most limiting factor when it comes to overclocking these CPUs. And you cannot run this kind of voltage 24/7. You would have to have something like a water chiller to run this kind of voltage, like in a daily situation. So the Dark is definitely capable of running these new CPUs. So for whatever reason, if you are getting a Cascade Lake-X CPU and you already have an X299 Dark, there's no reason to change your motherboard, as there are some motherboards coming out with the Cascade Lake-X CPUs. So would I recommend this CPU? It all depends on what you are running now. So if you already have a really nicely overclocking 7980XE or 9980XE, there's absolutely no point on buying a Cascade Lake-X CPU only to get like 100 or 200 extra megahertz on the actual core frequency. So that's the only real thing about the Cascade Lake-X. It is just a fine-tuned version of an architecture that already exists. It is just a fine-tuned Skylake-X, as they are all 14 nanometer CPUs. So we would just have to get a completely new architecture in order to see some actual IPC improvement. So the biggest thing about this whole launch is just the price. So we are seeing 40 to 50% cuts in the price tags, all of the different core counts that are coming out now. So and all of that goes to AMD, because AMD has been putting a lot of pressure on Intel's CPU monopoly over the past like 2 years or so, 2 to 3 years. So without AMD's recent achievements, this whole launch wouldn't even exist, pretty much. So they are just trying to fight off AMD by panicking and putting like so much like lower price tags on all of the core counts. That's pretty much it. The memory controller isn't any better, pretty much. So the increase from 2666 up to 2933 doesn't matter anything, pretty much. So with this CPU, I couldn't even run 4 GHz with the same memory timing profile. And when looking at my old results, so the first Skylake-X, 2066 CPU that I had, the 7920X, I could run almost 4133 with same timing profile with that CPU, with CPU on water. So that is so much better than what this CPU is doing. And I could even post 4200 MHz with CPU on water with exactly the same 6 sticks of memory and same memory timing profile. So it all depends on the IMC quality of your CPU. As all of the like the highest XMP kits, they are all beyond that default 2666 or even the 2933 already. So we are already like beyond the actual spec. So you have to test yourself and see how your IMC can actually do in a real world situation. So the increase in the stock rated memory frequency doesn't matter anything. So that's pretty much it. So if you have any questions or comments about this whole launch, please drop them down below, and please like and share this video if you liked it, and subscribe to my channel. And thanks for watching, and I'll see you next time.